Welcome back to Math 103. This is video number 4 on voting. Recall the election that we were looking at the very end last time, involving our old friends Pat, Sam, and Alex. We had, from the very first video, this somewhat intimidating-looking preference table. It's not so bad when you get used to it. And we asked, at the end last time, how many first-choice votes are needed to be a majority candidate in this election. And that leads us immediately to ask, how many voters are there in total, and what is the smallest whole number that is greater than half? So half of 50, because there are indeed 50 voters here. You might recall that from last time, or you might just count up. Right? So there are 50 voters. Half of 50 is 25. I caution you that the answer to this question is not 25. If you received only 25 first-choice votes, you would not have a majority. Okay, you would be one short of a majority. And therefore, 26 first-choice votes are needed in order to be a majority candidate. All right. The next question is, if we apply a certain voting method and Alex is declared the winner, does this election result violate the majority criterion? Actually, it does not, because there is no majority candidate. Notice that 26 first-choice votes would be needed to be a majority candidate. Pat has only 18, Sam has only 20, and Alex only 12, so there is no majority candidate, and therefore there can be no violation. The only thing that can go wrong, from the point of view of the majority criterion, is if there is a majority candidate who loses. If anything else happens, there is no violation. For any specific voting method, there are two possibilities. Either the method never violates the majority criterion, in other words, it is guaranteed, it is engineered so that it declares the majority candidate the winner of the election in every election which has a majority candidate in the first place. Some elections have no majority candidate, but in the ones that do have a majority candidate, the method certainly makes that candidate the winner. Okay, that's what it means to never violate the majority criterion. And the other possibility is that the method sometimes violates the majority criterion. In other words, there are some elections, maybe it's only 1 in a million, but there are some elections in which there is a majority candidate, but the method declares somebody else to be the winner. Every method is in one of these two categories. Either it never violates the majority criterion, or it sometimes violates the majority criterion. Ideally, every method would be in the first category. We will see that there are quite reasonable methods, surprising as this may sound. The majority criterion is very intuitive, but surprising as it may be, there are very reasonable methods that sometimes violate the majority criterion. So where does our one voting method that we have specifically looked at thus far stand? Well, the plurality method never violates the majority criterion. This is one of the good things about it. Think about why that's true. Let's pause a moment and just think about why that's true. Why is it the case that the plurality method never violates the majority criterion? Well, if there is a majority candidate, then that candidate has more than 50% of the first choice votes. That's just what it means to be a majority candidate. Well, if you have more than 50%, more than half of the first choice votes, then you certainly have a plurality. Okay? You certainly have more first choice votes than each individual opponent. Okay? And once you're a plurality candidate, the plurality method declares you the winner. Okay? So if you're a majority candidate, then you're a plurality candidate, and therefore you win under the plurality method. Okay? So just to rephrase that, if you have more first-choice votes than all your opponents combined, that's a majority, you certainly have more first-choice votes than each individual opponent. That's plurality. So if there is a majority candidate, a right candidate, then it is impossible for the plurality method to mess up and make the mistake of declaring someone else the winner. So this is a good thing about the plurality method. Okay? With regard to majority candidates, the plurality method always gets it right. Furthermore, the plurality method is straightforward and it's familiar. So what's wrong with the plurality method? Oh, let us count the ways. But let's begin with our example from Minnesota in 1998, where Ventura won the election. Right? He duly received more first-choice votes, 37 out of 100, 37%. He duly received more first-choice votes than any individual opponent, more than Coleman, more than Humphrey. But the plurality method is looking only at first-choice votes, and it is completely ignoring all this other information in the second and third-choice votes. Well, that's not so clever from a certain point of view, because you've got all of these many voters who have Ventura at the very bottom of their preference ballot. Now, those voters who went to the poll that day probably didn't imagine that this third-party candidate really had a chance of winning the election, but sure enough, he did. So there was a lot of discussion in the aftermath of that election of whether the plurality method really did the job we hoped it would of finding the overall will of the voters. So how do we remedy the flaws of the plurality method? One approach is the instant runoff voting method. Here's the idea. You bring everyone to the polls on election day, and you hope that one candidate will have a majority, an outright majority of first-choice votes. If so, great, they win. You hold your election, and maybe you find that there is no majority candidate. Well, you don't want to just declare the plurality candidate the winner, who's not a majority candidate, because then you get situations like the one from Minnesota in 1998. So what could you do instead? You could say that whoever receives fewest first-choice votes, in this case that's Humphrey, is eliminated, and we have a runoff election between Coleman and Ventura. Well, it would be very inconvenient to make everyone come back to the polling place 2 weeks later, so the brilliance of using preference ballots is that all their information for whom they would vote for in the runoff election is already on their preference ballot. Right? So these 28 voters right here who had Humphrey as their first choice will vote for Coleman in a runoff. We can, just for completeness, fix all the other ballots so that wherever Humphrey was eliminated and had someone else below him, the candidates below him move up. Right? So on these 35 ballots, Ventura moves up to second place to replace Humphrey, and on these 17 ballots, Coleman moves up to second place to replace Humphrey. But the ones that are most important right here are these 28 ballots on which Coleman is moving up to that vacated first-choice position. So as a result, in the new version, you've got 35 ballots that say Coleman first, Ventura second, another 28 ballots that say Coleman first, Ventura second, 20 that say Ventura first, Coleman second, and 17 that say Ventura first, Coleman second. So overall, okay, I'm just recording again the number of votes. Overall, Coleman now has 63 first-choice votes. And that means that Ventura has only 37, so now Coleman has a majority of the first-choice votes at this runoff stage. So Coleman wins. Coleman is declared the winner in this runoff election. So that is instant runoff voting. Let's look at a description of this in detail. So first, we're going to perform round one. In general, how does this work? Round one, you count the first choice votes for each candidate. Okay, so in this respect, it's similar to the plurality method. Initially, it's only looking at first choice votes, and we see, is there a majority? Does someone have a majority of first choice votes? If so, game over. That candidate is the winner. Right? So if there is a majority candidate, then we find out in round 1, and the election is over, that's the winner. If there's not a majority candidate, you eliminate the candidate with fewest first choice votes. Now, if it turns out, if you have a large number of candidates, if 2 or more candidates are tied for the dubious honor of having fewest first choice votes, eliminate both of them. Or perhaps there are a large number who are tied for having fewest first choice votes. If you had a really large number of candidates, there might be candidates who had no first choice votes at all. Okay. So, great. Round 2. Well, and we did this before, crossing out the names of those candidates who had been eliminated. And now you do a recount of the first choice votes. That's what we did earlier. We tallied up anew how many first choice votes Coleman had as a result of Humphrey departing. Okay? So when a candidate is eliminated from the preference table, in each column, the candidates below the eliminated one move up a spot. We indicated that earlier also. So if after moving the surviving candidates up, there's now a candidate with a majority of first choice votes, great, end of election, that's the winner. But maybe there's still not a candidate with a majority of first choice votes at that stage. Okay? If you have a large number of candidates, then this could go on for a while. Right? So if there's no candidate with a majority of first choice votes in round 2, then you do it again. Eliminate the candidate who currently has fewest first choice votes. You just keep on going until you finally end up with some candidate with a majority of first choice votes. This process is going to end eventually. So just as we had an extended plurality method, we have an extended instant runoff voting method, and that just means that we take all the work that we did to pick the winner and we rank the candidates. We produce an overall ranking of candidates. How does that work? Well, you look at the order in which they were eliminated, and then they are ranked in the opposite order. So in other words, whoever was eliminated first is going to receive the bottom spot in the ranking. Whoever won the election overall is going to be the top position in the ranking. Okay? The candidate who managed to survive until the final round, but then lost in the very final round, is number 2 in the overall ranking. So the number 2 candidate in the overall ranking is the last one who was eliminated. Now, before going on to the next video, find the winner of the following election under instant runoff voting, and then write down the overall ranking of the candidates under the extended instant runoff voting method.